Assalamualaikum. My name is Muhammad Uzaimi bin Madinah.
Assalamualaikum. My name is Muhammad Hakim Takiuddin bin Muhammad Hisham.
Assalamualaikum. My name is Muhammad Azam Bayhaki bin Muhammad Fakhur Razi.
Assalamualaikum. My name is Muhammad Aika bin Razali.
And we are from
Class DBM20023.
From kindergarten to now polytechnic, we have learned lots of mathematics. But do we actually know what is mathematics? Do we know the structure of mathematics? So today we look at the fields of mathematics for introduction. Okay, field or structure of mathematics have seven fields. Number 1, quantity. Number 2, applied mathematics. Number 3, discrete mathematics. Number 4, foundation and philosophy. Number 5, space. Number 6, change. And number 7, structure. So for differential, the fields is in change. Beside calculus, vector calculus, dynamical system, and chaos theory. So for differential equation, we listen to my next presenter, Azam. Go on, Azam.
To the differential equation history. Differential equation or DFQ is a branch of mathematics that start with one or many recorded observation of change and end with one or many functions that predict future outcome. And then DFQ possible made by two giants of math, which is Isaac Newton and Gottfried Leibniz. Then, as history tells, both men controversially claim to have independently invented calculus around the same time period. This is key since calculus, with the literal development of integral and derivative, set the stage for future mathematicians.
Okay, thank you Azam. Next slide. Back to our differential question. Firstly, our group need to solve two questions. For first question, we had used a technique of parametric differentiation. Secondly, and for second question, we had used application of differentiation technique and stationary points.
First question. An airplane is flying in a straight direction and at constant height of 5,000 meters. The angle of elevation of the airplane from its fixed point of observation is A. The speed of the airplane is 500 km per hour. What is the rate of change of angle A when it is 35 degrees? Express the answer in degrees per second and round to one decimal place. Step that we use to solve the equation is list all the information given and what to solve. B. Choose the right technique to find the answer. Trigonometric rules the derivative of x with respect to A. Second, parametric differentiation.
Thank you, Takiuddin, for read the question and what step we use to solve that question. Okay, now we list down all information that given and what to solve, what this question want. Okay, what is information in this question? We get is h, which h is height, equal to 5,000 meter. Okay, the speed is dx over dt. Why dx? Because speed go to front, so dx over dt 500 km per hour, but we change to meter per second because h in meter, so dx over dt should be in meter also. So 500 times 1000 we get in meter. Okay, divide by 60 times 60 for minutes and 60 second is for the second. So we get the dx over dt equal to 138.89 meter per second. Okay, for the question, at A, which A is the angle, at A equal to 25 degree, what is the rate of change A? dA over dt. What is the rate of change dA over dt? So we know what is question 1, and now step to solve all the question 1. Go on, Azam.
We go to the next step, which is choose the right technique to find the answer. And the first technique we use here is trigonometric rules, which is the derivative of x with respect to a. And the equation we got here is tangent a equals to h divided by x. And then we replace the h value with 5000, which is already have in the question above, and it will become tangent a equals to 5000 divided by x. And then we change the positions between x and tangent a, and then the equation will be x equal to 5000 divided by tangent a. And then x equals to 5000 open bracket tangent negative 1a close bracket, and we change it into x equals to 5000 open bracket cotangent a close bracket, and to find the answer dx per dA equals to negative 5000 cosecant square a. And we change the equation to negative 5000 open bracket 1 divided by sine square a, and the answer we got here is dx per dA equals to negative 5000 divided by sine square a.
Okay, we go the next slide. B. Choose the right technique to find the answer. Okay. Number 2, parametric differentiation. dA per dt equal dx per dt. Open confinement dx per dA negative 1. Okay, we equal 138.89. Open confinement negative 5000 per sin power 2a confinement power 1. Okay, dA per dt equal 138.89. Open confinement negative sin power a confinement, and we must divide 5000. Okay, when a equal 25 degree, dA per dt must equal 138.89. Open confinement negative sin to 25 degree confinement per 5000, and next we equal 138.89. Open confinement negative confinement 0.422 confinement power 2 confinement per 5000, and we must solve in confinement first. We get equal 138.89. Open confinement negative 0.426 confinement power 2 divide 5000. Next equal 138.89. Open confinement negative 0.1786 confinement per 5000. Okay, equal next equal negative 0.665 degree. We get the last answer, not the last answer again. Negative 0 degree 018. Okay, the answer is when the angle A is 25 degree, the rate of change of angle A is negative 0 degree 018 per second.
Second question. The farmer wished to fence off a rectangular sheep pen and use all of 100 meters of fencing. An adjoining hedge is to be used as one side of the pen. Determine the maximum area of the pen. Step we use to solve this question is list all the information given and what to solve. B. Choose the right technique to find the answer. Draw the diagram for more understand the question. area of rectangle formula, and stationary points technique.
Thank you, Taki, for the step to solve this question. But for better understanding, before we solve this question, we need to better understanding the question. Okay, rectangular sheet pan in bahasa Malaysia, kandang biri-biri segi empat tepat. Okay, adjoining hedge, pagar bersebelahan or pagar jiran sedia ada. Okay, what we this question one is maximum area, luas, maximum. Okay, and for better understanding, we draw some diagram. Okay, we draw hedge pagar jiran, and we draw three other side, which is two side is in parallel, which is in same long x. Okay, and the other side is 100, which is the total length of the fencing, minus 2x, minus the other two same longs of the fencing. So we got the rectangular shape, and after we got the rectangular shape, we can calculate the area, which is x times with 100 minus 2x meter. Okay, we got 100x minus 2x square for the area. Okay, Azam, go on with the other step to solve this question.
The area of the pan, which is we replace it with a, equals to 100x minus by 2x square. And a now is a function of x. For a stationary value of a, we must equate dA per dx equals by 0. And then dA per dx equals 100 minus 2 multiplied by 2x equals to 100 minus 4x. And let 100 minus 4x equal to 0, and we get the value of x is 25. And then in the slide 2 we have additional info, which is graph of a equals to 102x squared by using desmos.com apps. And as you can
see, in our question we know that a stationary value of a occurs at x equal 25. Next, we need to find the second derivative to determine or confirm its nature. Okay, firstly, d power 2a per dx per dx power of 2 equal negative 4, which is negative. Okay, a is maximum value when x equal 25. Okay, for the area, we must to find the y and length first. We must follow the formula. Okay, firstly a equal 100 x negative 100 x minus 2x power 2. Okay, in this area, the length is 25 meter. The y is 100 minus 2 confinement, 25 confinement equal 50 meter. Okay, the maximum area of the pan is 25 open 50 equal 1250 meter. 1250 meter too.
The summary for the first question is, when angle A is 25 degrees, the rate of change of angle A is minus 0 degrees, 0 minutes, and 80 seconds per second. Meanwhile, for the second question is, the maximum area of the pan is 25 multiplied 50 is equal to 1250 meters square.
Thank you. See you soon for maths presentation 2.